glass. First of all, don't laugh at my glasses, this thing's bright. But here is our project. It is this solar collector. It collects all the light rays and puts them into one focal point, which heats things up. So first thing I'm going to do for you is I'm going to find the focal point, and the camera can come over here so I can show you how I'm going to do that. Alright, I have this to find it visually. As you can see light around here, and it gets smaller, and then it gets in, out, in. So the focal point is exactly where the light rays meet, and it is about right there, right there. And so what I'm going to do is I'm going to just measure that, bring this down, right there. And it is about 18 inches. So the focal point is 18 inches on this thing. As you saw with the light rays from the sun, they came in here and they reflected and bounced right back. So basically, this is a concave mirror because all the light rays are directed here. So we're going to now show you some objects, and although it's just made of tin foil so you can't really see the objects, if it were clear, we're going to be able to do some math to show you exactly where these images would appear in their height. So we're putting this thermometer right here at 27 inches. So we're going to do some math for you right now with that. Alright, since we already know the focal point and the distance of the object, we're now going to find the distance of the image using this equation. So step 1, we're plugging in our values. We found that 45.7 centimeters was the focal point, and the distance of the thermometer was 68.6 centimeters. So we're going to subtract this value right here from this one, and that gives us this right here. And when we do this math right here, 1 over 0.0073 for the distance image, we find out that the distance of the image equals 136.9 centimeters. Alright, and now we're going to find the magnification and the height image of the thermometer. So we have this as our equation, and we're going to plug in the values. The height of the object was 13.9 centimeters, and this was our distance image over the distance of the object. And then once we do this math over here, we get 1.99 for our magnification. And then so we're going to use the magnification amount, and we're going to have the height over the image. We're going to do the math here, 13.9 cancel out, times 13.9 over here, and we find that our height of the image is 27.7 centimeters. Now we're getting the actual temperature. That was just an example, but I don't think you'll be able to see this one. And it is now climbing. It has hit 100 degrees Celsius. Okay, and the final temperature is 143 degrees Celsius, so it does get very hot. Alright, next, I'm going to melt something. I'm going to melt these lead pellets here, right here down here at my hand, because lead melts at extremely low points. I'm not exactly sure how low, so we'll see if it works. Let's cross our fingers. So what I did over here is I just pounded some lead pellets in here because I didn't know how else to hold them. So I'm going to put that one in there too. Just keep that one in there and hopefully these stay in, and let's see if they melt. Alright, going in for the focal point, and okay, we're just going to fast forward the camera now. Alright, so the block's almost lit on fire, so before that happens we want to test if it's melted, and it is not melted at all. That's lame. But we're going to show you the actual heat it takes to melt lead anyways, because that's a good part of the project. It's just that we failed melting these, which is okay. So as you remember, the solar converter didn't have enough heat to melt the lead, so we're going to find out right now using this equation. And this is mass times heat of fusion. So the heat of fusion for 1 kilogram of lead is 2.04 times 10 to the 4th joules. We only had 0.00284 kilograms of lead, one of those pellets that we needed to melt. So we multiply that by the amount of heat needed for 1 kilogram, and the heat energy, and then we get Q, which equals 57.93 joules kilogram. And that's how much heat we needed to melt the amount of lead we had. So now we're going to find out how much heat energy we actually got. So we have the mass of the lead we had times the specific heat of lead times the amount of heat we put in there. So 143 degrees Celsius was as hot as it got, and then that equals 52.79 joules kilogram. So then we do the heat energy had minus the heat energy needed, which is that minus this, and we get 5.14 joules kilogram of heat needed. So that's how much heat energy we were away from actually melting the lead. So we came pretty close. Okay class, we set out here to melt some lead today with the solar converter, but even though it reaches 140 degrees Celsius, it doesn't seem to want to melt anything or boil water. So we're going to still melt lead down here, still there, with the help of man's best friend, gasoline. And we have fire.
Dude, you're gonna light a fire.
Oh, good. Alright class, and let's not forget, it's the ends that justify the means.
You give me fire, give me that which I desire.
Yeah.
Turn on, I'll see you
Have melted lead.